And I'm going to share my screen. And first thing, a couple of announcements. Today we're going to look at finishing adding rational expressions, and we're going to look at complex fractions. That's the last of the new content. I don't know if I remembered to tell you guys the first day of classes, I think on the schedule for the Friday the 2nd, it says FCCC. It's the Faculty Council of Community Colleges. It's a conference that I have to attend. I'm the campus's representative to this SUNY organization, and so I need to be there, so we will not have class that day. And sadly, we're not quite where we want it to be, but the day that we're losing would have been a testing day. So because that would be the day that you guys would be taking your test. So homework P6 is due on Wednesday. The problem set is a practice test. It will be due on Friday. And exam 1, I will have available for you folks after class time on Wednesday, and it needs to be completed by Sunday. It is in my labs, and you need to submit your work in Blackboard. In order to submit your work in Blackboard, Blackboard likes JPG files. It doesn't like the JPEG files. It won't open those for me. It hasn't been really good at opening PDF files. I don't know why. If you submit something and I cannot open it, I will send you an email when I grade them and let you know that. If I send you an email that Blackboard won't open it, you can try to submit it again, or you can just email it to me. But right now, if we can get submission through Blackboard to work, again, I think it's safer. Work is less likely to get lost. Has anybody started looking at the problem set yet?
Yeah.
Okay. Because I was going to edit it and add a couple more questions, but if people have started it, I won't, and I'll just make sure. On Wednesday, the first part of my game plan is to go through a practice test with you folks to give you an idea what it's going to be like. There are a couple of questions that I added. I'll make sure we'll look at questions like those in class on Wednesday.
Are you talking about test 1 for Wednesday?
I'm talking about problem set 1 for Wednesday. Test 1, you'll be doing after Wednesday, before Sunday on your own time.
Okay.
Okay. Before we start looking at any of the new stuff, does anybody want to look at anything back homework-wise? Does anybody want to look at any homework questions? No homework questions? That's a surprise. All right, if there are no homework questions, then what we're going to look at today are adding and subtracting rational expressions without common denominators. And then we'll look at complex fractions. And so in order to add and subtract fractions without a common denominator, and I hear a little bit of a feedback. If you're not speaking, please mute yourself. But again, if you have a question, please unmute yourself and ask it. When we look at adding and subtracting fractions that don't have a common denominator, the first thing we need to do is find the least common denominator. In order to do that, we have to factor each denominator completely. And what happens is the LCD is the product, so we have to multiply, of all the factors from each. If there's a common factor, we're going to use the highest exponent. So the first thing we have to do is find the lowest common denominator. In order to do that, we have to factor each denominator completely. And then when we look for the lowest common denominator, we're looking to make a product of all of the factors that we see. If there's a common factor, we're going to use the highest exponent that it has in either denominator. So what does all of that mean? Let's start with a simple example and gradually work our way harder. First example, let's look at 3 over 2x plus 4 plus 2 over 3x plus 6. Is it obvious to everybody that these two fractions have different denominators?
Yeah.
Yeah. So to find that common denominator, the first thing we have to do is factor each denominator. And so can anybody help me factor 2x plus 4?
2 times x plus 2.
And can anybody help me factor the 3x plus 6?
3 times x plus 2.
So for my common denominator, from the first one I need a factor of 2, and I need a factor of x plus 2. From the second one, I need a factor of 3, and I need a factor of x plus 2. But do you notice each of the x plus 2's, they only have an exponent of 1? So I only need one of them in my common denominator. The highest exponent on x plus 2 is 1, so I'm going to just have x plus 2 to the first. It's in there already. Everybody all right with that choice for common denominator? In my mind, it's just kind of making a grocery list of the factors I have. Second thing we're going to do then is express each fraction in terms of the common denominator. By multiplying both the numerator and the denominator of that fraction by, I call it any missing factors. And by missing factors, I mean factors of the LCD that are not factors of that denominator. So we're going to take each fraction and try to make it get the common denominator. And this process looks very, very similar to the way you would do it with numbers. You're going to look at each denominator and say, what factor does it need to turn into the common denominator? What's missing? And multiply numerator and denominator by that. You must multiply the numerators out. You can leave the denominators factored. We have to multiply those numerators out, but it's okay to leave the denominators factored. Because we're going to find even if you multiply them out, you will eventually have to factor them, so why bother? You can get a little bit lazy and leave denominators factors, but you must multiply the numerators out because we're going to be adding them. In order of operations, you have to multiply before you add. So, all of that rambling, what's it mean in terms of our problem? Can I scooch this up?
Yep.
We said that our LCD turns out to be 6 times x plus 2. My first fraction was 3 over 2 times x plus 2. What do I have to multiply 2 times x plus 2 by in order to get that common denominator, 6 times x plus 2?
3.
So if I multiply the denominator by 3, I have to multiply the numerator by 3. I always take the time to write that out because when I look at this, it shouts out at me, I'm only multiplying by 1. I only want to multiply by something equal to 1 because I don't want to change what the fraction equals. I just want to change what it looks like. So that's going to be 9 in the numerator, and my denominator is now that 6 times x plus 2. My other fraction was 2 over 3 times x plus 2. And what would I have to multiply this denominator by in order to turn it into my common denominator?
2.
And if I multiply the denominator by 2, I'm going to multiply the numerator by 2. I'm going to multiply the numerators out. 2 times 2 is 4. And I'm going to leave that denominator factored 6 times x plus 2. And now my two fractions have the same denominator. Since they have that common denominator, third thing I'm going to do is add if it's an addition problem, or subtract if it's a subtraction problem. And again, with subtraction, remember to watch your signs. And then, if possible, simplify. So I cheated and wrote 2 steps as one. So our first fraction became 9 over 6 times x plus 2. Our second fraction became 4 over 6 times x plus 2. They have a common denominator. We worked hard to get it. So we're going to keep that common denominator. We're going to add the numerators. And now this one, because 13 is a prime number and it's just a number, it's not going to simplify. And so my final answer would be 13 over 6 times x plus 2. How's that one?
Good.
Good. Should we try one a little bit harder?
Yeah.
Let's look at 3x over x plus 4 plus 6 over, whoops, where'd it go? There it is, 6 over x plus 5. First thing I need is a common denominator. I'm looking at that first denominator, x plus 4. Does x plus 4 factor?
No.
No, it's prime, so we need a factor of x plus 4 from the first one. And in the same way, x plus 5 doesn't factor, so we need a factor of x plus 5. So this time my common denominator is x plus 4 plus x plus 5. So that first fraction is 3 over x plus 4. I wanted to have a denominator of x plus 4 times x plus 5. Is it obvious I need to multiply the denominator by x plus 5 to get there? And again, whatever I do to the denominator, I have to do the same thing to the numerator. And I apologize, that was 3x in that numerator, not just the number 3. I can leave my denominator factored, but I've got to multiply that numerator out. So over here, I have to distribute. And that becomes 3x squared plus 15x. First fraction okay with everybody? If so, that was so much fun. We want to do that type of work again. But this time we're going to start with our 6 over x plus 5. And we're wondering, what do we need to multiply it by? So that new denominator is x plus 4. times x plus 5. And does everybody see we need the x plus 4? And what I do to the denominator, I have to do the same thing to the numerator. I want to make sure I'm multiplying top and bottom by the same value because that makes that fraction equal to 1. In the numerator, when we distribute, we get 6x plus 24. Now that they have a common denominator, I can add them. And when I add them, I'm going to keep that denominator. But I have to add the numerator. So I'm going to take that 3x squared plus 15x and add to it that 6x plus 24. And so when I add, I get 3x squared plus 21x plus 24 over x plus 4, x plus 5. Now, I have to see if it can simplify. In order to simplify it, I'd have to factor that numerator. So that numerator is 3x squared plus 21x plus 24. And let's see, there's a common factor of 3, leaving me with x squared plus 7x plus 8. And let's see, 8 can be 1 times 8 or 2 times 4. But with common signs, I will never get that 7 in the middle. So it's not going to really factor any further. It has no common factors with the denominator. And so this is going to be my final answer. Is everybody all right if it asks you what values to exclude? We're looking at the domain. We're looking at where any of these fractions are undefined. So I'm going to scooch up to the original fractions. My original denominators are x plus 4, x plus 5. My new denominator is the product. So I'm worried, where does that give me a 0 in the denominator? Well, x plus 4 equals 0 if x is negative 4. X plus 5 equals 0 if x is negative 5. So they'd say x cannot equal, and it can't equal negative 5 or negative 4. And so when they're asking you in any of these problems, what values do I exclude? Or if you ever in any of these problems see that x cannot equal, and then there's a blank there, what you're going to put in that blank is any value that gives you a 0 in the denominator. As we had said, denominators can never equal 0. It has no meaning. How's that one? If that's all right, I've got 2 more of these to look at, and then we'll start looking at complex fractions. Can I turn the page?
Yeah.
The next example, I've got 3x over x squared plus 3x minus 10 minus 2x over x squared plus x minus 6. And so my fractions have different denominators. So the first thing I need to find is the least common denominator. And in order to do that, what should I do first?
Factor.
Factor. Don't worry about the numerators. We're not going to factor the numerators of these until the very, very, very last step. but we do worry about the denominators. And so that first one, x squared plus 3x minus 10. To get x squared is going to be x and x. To get 10, I'm thinking 5 and 2. What do you think? Plus 5 minus 2, would that give me that positive 3 in the middle?
Yeah.
And then my second one, x squared plus x minus 6. I'm going to hit x squared is going to be x and x. For 6, I'm thinking let's use 3 and 2. Signs are different because it's a negative 6. I think if I have a positive 3 and a negative 2, I'll get that positive 1 in the middle. So now when I look for my common denominator, I have to list all of the factors I see. And I'm only going to put an exponent on it. I'm only going to reuse a factor if it shows up more than once in one fraction, if it shows up in either fraction with an exponent. So the first one, I need x plus 5. I need, from the first one, x minus 2. From the next one, I need x plus 3. And then I also need an x minus 2. But does everybody notice the x minus 2 is in there already? So that'll be my common denominator. In neither fraction is x minus 2 got an exponent, so I think that's all we need. No, I don't want to draw with my fingertip. Yikes, let me undo that. I want to change the line width. And it's not letting me, so I guess we won't. So we now want to express each fraction with their common denominator. So I've got 3x over x plus 5, x minus 2. And I want that to have as its denominator the common one, x plus 5, x minus 2, x plus 3. So which of these factors is it missing? It doesn't have the x plus 3, so I'm going to multiply both numerator and denominator by it. Is everybody comfortable with why I made that decision?
Yeah.
So when we multiply those numerators out, we've got to distribute, leaving me with 3x squared plus 15x. And then the second fraction is 2x over x plus 3.
How did you get 15x?
I had, because I made a careless mistake. Thank you for catching it. What should it be instead?
9.
9. 3 times 3 is 9. I guess my fingers and toes weren't working fast enough on that one. I'm so sorry. Thanks for keeping me honest. Actually, I was looking to see if you were awake, right? Oh boy. We want the denominator to be x plus 5, x minus 2, x plus 3. And let's see, it's missing the x plus 5. If I multiply the denominator by that, I have to multiply the numerator by that. That's just a plain old x plus 5. When I distribute this time, do I get 2x squared plus 10x? Did I do okay with that one? Besides the bigger denominator, the other thing that makes this one a little bit dicier is the fact that it is subtraction. And since it's subtraction, I've got to watch my signs. They both have my common denominator. So I'm going to write them both over the denominator, x plus 5, x minus 2, x plus 3. But this time, first numerator is 3x squared plus 9x. Second numerator is 2x squared plus 10x, but this time I'm subtracting. And to avoid careless mistakes with subtraction, is there anybody else who likes to think of it as distributing that -1? So my numerator is now 3x squared plus 9x minus 2x squared minus 10x over that common denominator. Work hard for that denominator. I'm going to keep it, at least for a while. In the numerators, now that they're multiplied out, and I've distributed the -1, I've got some like terms I can combine. 3x squared minus 2x squared is 1x squared, plus 9x minus 10x is minus x. And now we're wondering, can that be reduced? Well, the numerator factors, there's a common factor of x. The other factor would be x minus 1. And it has absolutely no factors in common with the denominator, so I'm going to stop there. How's that one? If it's all right, I'm going to try one more. Let's look at x over x squared minus 10x plus 25 plus 5 over x squared minus 25. I'm going to be quiet for a minute and ask you folks to factor and see if you can find that common denominator. So could everybody on your own please factor each denominator and tell me what you think that common denominator should be. How'd I do? Did everybody get that first denominator to factor into x minus 5 times x minus 5, which it makes it x minus 5 squared. And the second one is x plus 5 times x minus 5. All my factors are x plus 5 and x minus 5. But with this one, I need to square the x minus 5 because the one fraction has two factors of that. So far, so good. So now the first one is x over x minus 5 squared, and we want it to have a denominator of x minus 5 squared times x plus 5. Is it obvious to everybody we need to multiply both the numerator and the denominator by x plus 5? And that we've got to multiply out. Don't leave that one factor. Distributing here, we get x squared plus 5x. And the next one, we had 5 over x plus 5, x minus 5. And we want that to get that denominator, x minus 5 squared times x plus 5. And in order to get there, we'd have to multiply top and bottom by x minus 5. And so that gives me 5x minus 25. Doing good so far, folks, or no? Am I going okay? Am I going too fast? Am I going too slow? Where are you?
I'm good.
You're fine.
You're fine? Okay. So now we've got that common denominator. We worked hard to get it, so we're going to keep it. X minus 5 squared times x plus 5. And in the numerator, we have x squared plus 5x plus 5x minus 25. And so that gives me x squared plus 10x minus 25 over x minus 5 squared times x plus 5. And I'm looking at that numerator, and I don't think it factors. And so I do believe that that's the final answer. And I want to tell you that I could not get to that final answer from this original problem without doing all of the work in between. And so these problems I don't think are that difficult, but there's a lot of work, a lot of things that are going on. None of it's that, super hard as long as you're comfortable with the factoring, but you do have to, work them out one step at a time. Find the common denominator.
Do we have to write x minus 5 squared, or could we write it out twice? Like
You could write it out twice.
Okay.
If you really, really wanted to, you could write that out as x minus 5 times x minus 5 times x plus 5. But can I tell you, I think these problems have way too much writing in them already. So I think the x minus 5 squared is less writing. I'm lazy. If you want to write it all out, though, you're good as gold. Okay? If adding and subtracting are all right, then the next place we're going has a fun name. Can I turn the page and not lose anybody?
I have a question.
Okay.
First, before we get the answer, it's x squared plus 5x minus 25.
Uh-huh.
Why don't we factor that and then cancel out things?
Because if you were to factor that and cancel things out, what would happen is it would take you'd undo the common denominator. It would take you back to the original problem, right? If I tried to reduce either of these fractions before I added them, it would undo all of the work that I just did. So with these, you're only going to factor the numerator in that very last step. With these, you're going to multiply the numerators out, add what you can, combine like terms, and then and only then after you've done your addition will you try to reduce it. All right?
Okay.
Okay. And honestly, it's that's a good question to ask, because I know usually with an in-class test, people some people kind of like feel like under pressure, and under the pressure of the moment they start trying to reduce things, and you really can't until after you've done your addition, because otherwise all you're doing is undoing the work you just did. And we don't want to do that. We took too long. So, but if those are all right, last new thing we're looking at, for at least the last new thing we're looking at in the month, no, we're going to do a little bit of new notes next class. One of the last new things we're looking at in the month of September is the idea of complex fractions. Has anybody ever heard of a complex fraction? A complex fraction is a fraction with a fraction in its numerator or denominator. So we want to simplify them by getting rid of the fractions within the fraction. There's a couple of different approaches that you could take. Rather than showing you a whole bunch of ways of doing this, I'm going to show you what I personally think is the easiest way. And so to simplify, what I'm going to do is I'm going to find the lowest common denominator of all the fractions within the fraction. So what does that mean? Let's look at an example. Let's look at x over 3 minus 1 over x minus 3. And does everybody see that this is a complex fraction because there's a fraction within the fraction? Because there's only one fraction within that fraction, the least common denominator is going to be that denominator, or 3. Now that we've got our common denominator, what we're going to do is we're going to multiply both the numerator and denominator by the least common denominator. Sometimes we write it as the least common denominator over 1, and we have to distribute where necessary. What does that mean? Can I scroll up a little bit and not lose anybody? I have x over 3 minus 1 over x minus 3. Again, I want to do the same thing, numerator and denominator. So I'm going to multiply it by 3 over 3. When I multiply the numerator by 3, I have to distribute. That gives me 3 times x over 3 minus 3 times 1. In the denominator, when I distribute, I get 3 times x minus 3 times 3. And now what's really cool, over here, I can think of this 3 as 3 over 1. And if I've chosen my correct common denominator, do you see how over here those 3's would cancel as a common factor? And that's going to leave me with x, I'm sorry, I said x and I didn't write it, I apologize. Leaves me with x minus 3, and in the denominator I'd have 3x minus 9. And now I'm going to simplify if possible. And again, in order to simplify a fraction, we have to factor first. That denominator factors into 3 times x minus 3. So there is a common factor. That 3 that's left is in the denominator. When we divide the x minus 3 by itself, we get a 1. And so my simplest form is 1/3. How's it look?
Good.
Should we try some more?
Good.
Yeah.
Let's look at 1 over x squared. Oh, this screen is so sensitive today. I just have to hold the pen near it. That's why everything's got a squiggly line. It writes before it touches the screen. Plus 2 over x minus 3 over 1 over x squared plus 1. My fractions have denominators of x squared, x, and 1. Is everybody all right? The common denominator, all I'm seeing are factors of x and 1. And so my common denominator has to have a factor of x. The highest exponent is 2, so my common denominator is x squared. That part all right? If so, I'm going to take the numerator and multiply it by x squared, and I'm going to take the denominator and multiply it by x squared. I'm doing the same thing to the numerator and denominator, so I'm just multiplying it by 1, not changing the value. We have to distribute in the numerator. So that gives me x squared times 1 over x squared. So I'll put that 1 over 1. Plus x squared times 2 over x. I'll put that over 1. Minus x squared times 3 over, in the denominator, I'll have x squared over 1 times 1 over x squared plus 1 times x squared. Is that distribution step all right for everybody? Wrote that step out because now I can see when I multiply the first one, the x squared's gone, gives me 1. The second one, I can put x into x squared x times, and so that leaves me with plus 2x minus 3x squared. And in the denominator, the x squareds would cancel, leaving me with 1 plus x squared. Now, it'll only simplify if the numerator and or the denominator factors. And I look at that denominator, 1 plus x squared. And while 1 and x squared are both perfect squares, because it's got the plus sign in between, it's not going to factor. So this one won't simplify, so I'm going to stop here. Everybody all right?
Yeah.
Got one more I'd like you to try. Can I turn the page?
Yeah.
Okay, thank you. What if I have y to the negative 1 minus, in parentheses, y plus 5 to the negative 1 over 5. Huh. Does this look like a complex fraction to anybody? Does anybody see any fractions within this fraction? Why did I put this problem here?
The answer 1/5.
Nope.
Okay.
Is everybody all right? That y to the negative 1, doesn't that mean 1 over y? aren't my negative exponents a shorthand way of writing a fraction? So that one's 1 over y. And then the second one, isn't it 1 over what's being raised to the power, y plus 5? And I've got that over 5. So between those three terms, I have to find the lowest common denominator. I'm open to suggestions. What do you folks think I need in my common denominator? Nobody? From the first one, I need a y. From the second denominator, I need a y plus 5. And then that 5, I can think of that as 5 over 1. So its denominator is 1, so I don't need to add anything. So the common denominator is y times y plus 5. So I'm going to take that numerator, 1 over y, minus 1 over y plus 5, and multiply the numerator by y times y plus 5. And I'm going to take that denominator, 5, and multiply it by y times y plus 5. Does everybody see the need to distribute in the numerator? So I'll have that y times y plus 5 times 1 over y. Might put this over 1 to make it clearer. Minus y times y plus 5 times 1 over y plus 5. And again, I like to put that over 1. And then in the denominator, I'll be ending up with 5y times y plus 5. And it's a lot of writing, but really so far all we've done is find that common denominator and distribute it to both the numerator and the denominator. Again, making sure I'm multiplying both the numerator and denominator by the same thing, so that I'm multiplying by 1. Now, if we chose the right common denominator, after this multiplication, we should not have fractions left within the fraction. So this first product, the y's cancel. I'm left with y plus 5. The second product, the y plus 5's cancel. So I'm left with minus 5, y. In the denominator, I have 5y times y plus 5. When I combine like terms in the numerator, y minus y is 0, so that leaves me with 5 over 5 times y plus 5. And now I can simplify those 5's out. It leaves me with y times y plus 5 in the denominator. And in the numerator, when I divide out that 5, I'm left with 1. So this is that final answer. Thoughts? We okay?
Yeah.
Okay. I've got that we've got quite a few minutes left. I was really afraid that I wouldn't be able to get through both the addition and subtraction and the complex fractions in one day. But based on what you folks are telling me, it sounds like you've got it. In the time that remains, we can do another example or two. Would you rather do another example of adding and subtracting fractions? Or would you rather do another example of complex fractions?
Complex.
Complex. All right. Let's look at, I'll do the same one that I did with the other section. And I pulled this out of the textbook. Let's look at 6 over x squared plus 2x minus 15 minus 1 over x minus 3 all over 1 over x plus 5 plus 1. Wow. How fun is that? We're going to start by finding the least common denominator of the fractions within the fraction. In order to get that common denominator, we have to factor each common denominator. So let's see, that first denominator underneath the 6. How would you guys factor x squared plus 2x minus 15? Any ideas?
X plus 5 and then x minus 3.
Beautiful. X plus 5, x minus 3. That second denominator is x minus 3. In the denominator, the next denominator is x plus 5. And 1 has a denominator of 1. We can think of it as 1 over 1. So between all of the fractions within that fraction, what would you tell me the least common denominator is?
X plus 5.
Need a factor of x plus 5. Do we need anything else?
And then x minus 3.
X minus 3. Beautiful. So now we've got that common denominator. We're going to multiply both the numerator and the denominator of that fraction by the common denominator, x plus 5, x minus 3. In the numerator, when I distribute, I'll have that first fraction, 6 over x plus 5, x minus 3, times the common denominator, x plus 5, x minus 3, minus the second fraction, 1 over x minus 3, times the common denominator, x plus 5, x minus 3. In the denominator, when I distribute, I'll have that first fraction, 1 over x plus 5, times the common denominator, x plus 5, x minus 3, plus 1 times x plus 5, x minus 3. Lots of writing, but is everybody comfortable with that distribution? Now I've got my fingers and toes crossed because I'm hoping that I picked the right common denominator. Because if I did, when I do this multiplication, everything should cancel out. See, the x plus 5s are gone and leave me with no fractions. That fraction's gone. This time I've got minus 1 times x plus 5. There's no fraction left there. Down here, the x plus 5s are gone, leaving me with 1 times x minus 3. And then here I have x plus 5, x minus 3. So there are no fractions left, but now we have to simplify. In order to simplify, think about using your order of operations. Before I can add or subtract, I have to distribute. So let's look at the numerator first. That becomes 6 minus x minus 5. And so let's see, when I subtract that, I get 1 minus x. In the denominator, distributing the 1 gives me x minus 3. And then I have to FOIL that out, giving me x squared minus 3x plus 5x minus 15. And so when I combine like terms in the denominator, I've got x squared, let's see, x minus 3x is minus 2x plus 5x is plus 2x. And minus 3 minus 15 is minus 18. And I'm looking at that denominator. The 18 can be 1 times 18. That won't give me, with different signs, that won't give me a 2. 2 times 9 won't give me a 2. 6 times 3 won't give me a 2. So I don't think that factors, so I don't think that reduces. So I do believe that that's our final answer. What do you think? We good? Any questions? If not, does anybody want to see another addition or subtraction problem done out, or are we good?
We're good.
Okay, if we're good, then I'm going to stop sharing. I'm going to stop recording.